Good morning and welcome back to Brodeur on this Tuesday morning. We are on day 2 of week 5. We just wrapped up graphing yesterday, graphing systems of equations. So today we're actually going to move into my favorite personal method for systems of equations, and that is elimination. And so let's talk about that. Our learning intention for today is students can find a solution to a system of two linear equations algebraically using the elimination method. So let's jump in, let's get rolling on this right here. So right here, we're going to talk about two problems today for elimination method. This one you can find in the examples that are kind of written out for you on your packet. And example 2 is actually going to be one of the problems you need to complete today. So if you do this one with me, that only leaves you 3 more problems you have to complete to get a 100. So let's dive in, let's talk about this. If you remember from yesterday when we were graphing systems of equations, you might say, Mr. Brodeur, this doesn't really look like the same type of equations. And that's because yesterday we were dealing with y equals mx plus b, or in other words, we call this formula slope-intercept form. Now today, we're not dealing with slope-intercept form because we don't need a graph. We need to use the elimination method. So we're going to have what we call standard form, where we have the x and the y on the same side and the constant, or the number by itself, on the right side. Now in order to do elimination, the key is we got to solve for both x and y, but we can't do that if we have two variables. So we need to, in essence, eliminate one of the variables. And in order to do that, we're just going to go over and we're going to kind of add our two equations together and see if any of our variables eliminate. Here, if I do 3x plus, and this is really a 1 right there, so 3x plus 1x, that gives me 4. Clearly, the x's do not get eliminated. But negative 4 plus 4 does. That gives me 0, which is perfect. I want one of my variables to eliminate, and that happens here. So we can move forward and add our equations together. So 3 plus 1 gives me 4x. Negative 4 plus 4 gives me 0y. And then 10 minus 2 gives me 8. So this is perfect. This y variable gets eliminated. Now some people might say, Mr. Brodeur, if it gets eliminated, why do you still have y there? Well, I wanted to show you that it becomes 0y, but most of us know, well, Mr. Brodeur, that's just 0 right there. So if that's just 0, because anything times 0 is 0, I don't necessarily have to write that because adding 0 is not going to change the value. So I'm going to do 4x equals 8 and forget about that 0y right there. Now, most of you guys at this point would go, oh, this is really easy. I could easily solve for x, and hopefully you would say, well, all I would have to do is divide by 4 to both sides. That would give me x equals 2, and boom, you have one of your answers. Notice I said one of your answers. You need 2 answers. You need your x answer and your y answer. So I got my x answer right here. But if you think back to yesterday with graphing, we wrote our final answer in an ordered pair or coordinate form. So I'm going to write my x first, because usually your ordered pairs are x comma y. But now I have to find my y. And this is how you find the y. Once you get one of your variables, you're going to take that variable and plug it into one of the equations above. It does not matter which one you plug it into. For me, I'm just going to plug it into the top one, but if you decided to plug it into the bottom, you would find you would get the same answer for y. So I'm going to take this equation, 3x minus 4y equals 10. But notice I'm going to leave x blank because I'm going to replace him with 2 in just a second. So 3x minus 4y equals 10, but I'm going to take this 2 and I'm going to plug them in for x right there, and now I can go about solving for y. So 3 times 2 gives me 6, minus 4y equals 10, and now I'm going to go and solve for y. So I'm going to subtract 6 to both sides. Right there. Notice I did the inverse operation to get y alone. That gives me negative 4y equals y right there. And just kind of like what we did here with the x, I'm just going to go ahead and solve for y. I'm going to divide, notice not by 4, but by negative 4. And that gives me y equals negative 1. You should get the same answer if you plugged it into the second equation as well. And so I'm just going to bring that negative 1, plug it into my coordinate pair or ordered pair, and that would be your final answer. So that's what we're looking for right there. This would also be what we call a one solution because, of course, there's only one solution, one answer right there. Now, the last one right here I want to talk about is example number 2. Now, notice right here, if I want to go to solve this one, you might say, well, Mr. Brodeur, 2 plus 2 gives me 4. 3 plus 3 gives me 6. None of those get eliminated. So instead of adding our equations, we are going to subtract our two equations. And if I do that, 2 minus 2, that would then eliminate. That would actually give us 0. But when you subtract, here's the big kicker. This is the thing you got to remember. You got to take your negative and you got to distribute it to all three terms. So let's rewrite this. I'm going to bring down my top equation, 2x plus 3y equals 21. Now the bottom equation is now going to be negative 2x minus 3y minus 21 right there. Now, like we said, 2x minus 2x, that gives me 0x. So boom, that's great. We eliminated one of our variables. But we get into a weird situation that happens sometimes. Not all the time, but sometimes. Usually one term gets eliminated, one variable gets eliminated. But in this case, 3 minus 3 also gets a 0. And so this is a weird case. Also, this is weird too. 21 minus 21 gives us 0. Everything seems to get eliminated right here. Don't freak out. Like I said, this is a rare case, but this would become 0x plus 0y. That would become 0. This side would become 0. So we do not have any variables left over. That means it cannot be a one solution like we had over here. That means we're going to have one of the cases we had with graphing, no solution or infinite many. How can I determine that? Well, the first thing I'm going to ask myself is 0 equals 0 a true statement? That is true. 0 does equal 0. Since that is a true statement, that means it would be infinite many solutions. Okay? So infinite many solutions. Now you might be thinking, what would be an example of a no solution? No solution would be if our variables canceled out. Let's say our variables canceled out and you had 0, but you didn't have 0 on the other side. You had something like 3 or another random number. That wouldn't be a true statement. Those two things do not equal each other. This would be an example of a no, whoops, let me write that a little bit better. A no solution, okay? But in this case, of course, we had infinite many solutions. We didn't have a no solution, but that's what you would get in those type of scenarios. So I'm hoping this helped you guys out and kind of put you through a lot of different scenarios and examples. But just let us know if you have any questions. Let your teachers know. Send us emails. We'd be glad to help. But until next time, Brodeur out. Peace.